A very warm welcome. I am Rishabh Atulkar. My topic for thesis is Framework for Designing Bicycle Route Network to Facilitate Bicycle Use, a case study of Bhopal. I'll give you a comprehensive insight on the problem statement and step-by-step solution of its implementation process. So, let's get in action. Let's start with the introduction. Most of the urban residents are dependent on non-motorized transport. This is because many of them cannot afford them or are captive users. A study shows 13% to 21% of existing bicycle mode share in 19 of major cities, of which many of them had an average trip length of 3 km or less. These trips are ideal for non-motorized transport. Similarly, various studies are conducted in Bhopal orienting towards NMT users. Among them, a study conducted by BMC shows that 43% people commuted to the place of purpose by walk. Another study by Embark shows that mode share in Bhopal for walking and cycling accounts for 53%. This shows the potential for bicycle-oriented mobility plan in the city. The city already has a full-fledged public bicycle sharing system having 50 dock stations, and it was a success in its initial months, but in time, people retorted the system with averting risks caused by road accidents. Road safety has always been the main issue for the bicyclist. This issue can also be addressed at national level. The traffic is worse hit by road accidents rather than pollution or environmental exposure. India accounts for 11% of road traffic deaths. However, many efforts have been taken by the government to improve the road safety, but still it continues to be a major deterrent to the road traffic. Other major issues such as social perception, discouraging traffic rules, poor intersection design, inadequate or negligible infrastructure, etc., have only contributed to the menace and forced people to retort from availing bicycle as a mode of transport. Hence, my study aims at assessing the level of bicycle facilities in Bhopal city region and formulating a framework for designing bicycle route network and related infrastructure to facilitate bicycle use. Broad objectives are to determine the extent and volume of demand, design of route network, and finally, develop a framework to promote and facilitate bicycle use. Broader scope refers to demand assessment for infrastructure, development of BLOS index, identifying parameters suitable for service quality attributes, catchment area determination forming network density, and finally, developing a framework for the provision and improvement of road network. Study will not focus on the financial auditing, calculation of pollution indicators, and DCR for integration of land use and transport planning. Also, it is restricted only to infrastructural improvement rather than overall accessibility improvement. Now, we will throw light on the overview of study area. Known as the City of Lakes, it's the 16th largest and among the greenest cities in India. The city has a total population of around 18 lakhs under the BMC boundary. It's one of the most rail-connected cities in India with more than 200 trains per day. It also has an international airport within 15 km of city center. NH46 forms a ring road around Bhopal, which connects it to other districts in the state. Falling just north of the upper limit of the Vindhya mountain range, it has an average elevation of 498 meters. Since the city has uneven elevation, this factor plays an important role in determining the route network. Due to the topological constraints, the city has the shape of an arc in a clockwise manner from northwest towards south, with urban sprawl on the eastern and southeastern boundaries. The city was conceived as 5 self-contained units with view to achieving flexibility in land use. Interestingly, the development plan does not propose any changes in the old Bhopal area, which preserves the status quo and is a symbol of the city. Hence, this core area offers a great opportunity for the development of bicycle route network due to crowding of narrow and congested streets and its high demand for bicycle infrastructure in the service area of commercial hubs. There are a significant number of users who access these commercial hubs for their daily needs and predominantly for employment in a serviceable area having range of 5 kilometers around this chunk of land. Hence, the region is divided in 8 analysis zones depending on the similar street pattern and socio-economic characteristics. The following images show a glance at the congestion, compactness, and fragility of the study area. Now, let's briefly discuss about the research methodology. The framework is designed in 6 stages. Firstly, identifying attributes for level of satisfaction and importance in intention to use bicycle. Then, comparing these attributes on the basis of perception and ranking them using credit scoring. Further, conducting factor analysis to enlighten attributes that are useful indicators. Thirdly, developing BLOS index of parameters for overall satisfaction. Further, investigating the catchment boundary of the service area of commercial hubs. Then, identifying routes based on user demand, shortest path, closest facility, and so forth. Finally, the outcome developing the network density for bicycle routes. The workflow deliverables is as follows. Firstly, data is collected fulfilling individual objectives. Data on ward-wise population density is done to analyze the distribution of population in all wards. To remove the mode-specific bias, equal number of bicyclists and non-bicyclists were surveyed. The map shows the OD points of all respondents. The road inventory survey was done by physical marking and AV recordings which included information on land use abutting the road stretches, road conditions, ROW stretches, footpath width and availability, road encroachment, on-street parking and so forth. A total of 30 intersections were considered for TVC survey. The study was conducted in both morning and evening peak hours with time interval of 2 hours. It can be summarized that this data is helpful in determining which network requires infrastructure or improvement, present scenario of the respondents, their demand, and their perception on level of importance and satisfaction. Now, coming towards data analysis. Data collected on socio-economic characteristics of all respondents reveals the requirements of users based on age, gender, education, occupation, monthly household income, and so forth. Data on trip characteristics show that nearly 62% of all traveled for work purpose. 75% of the people traveled at an average distance of 2 to 5 kilometers, which reveals that they all reside in or around the periphery of the study area. Thus, the planning shall be focusing on these factors. Next, rated scoring is done on two different sets of perception attributes, qualitative and quantitative. In this scoring, data required for calculation is user's level of importance towards perceived service attributes. The scoring reveals that street lighting, flexibility of mode, psychological perception of low social status, segregation from motorized vehicular traffic, and the fact that bicycle is the cheapest mode are considered as the most important attributes in determining the intention to use bicycle. While scoring of quantitative attributes reveals space for cycling, number of pedestrians, and on-street parking as the most important factor. Next, factor analysis is done on all 35 quality attributes, in this case, exploratory factor analysis, to check which factor is a good indicator for service quality of bicycle routes. Using principal axis factoring, it was revealed that only 17 variables showed good factor loadings and were clubbed in 4 factors, namely security and efficiency, infrastructure and traffic conditions, comfort and convenience, and psychological conditions. The results of EFA are validated through CFA, confirmatory factor analysis. The benchmark CFA revealed that few attributes co-varied each other, hence removal of one of them would enhance the model. Thus, another model was constructed. It was revealed that both models returned an acceptable degree of model fit, but Model 2 seems to be more favorable for analysis. Further, Spearman's correlation analysis displayed strong and significant correlation coefficients showing low multicollinearity and significant interaction between variables. The regression model results display that all latent parameters display some degree of effect on user satisfaction with the overall service quality of bicycle routes. Next, a BLOS model is developed to predict the level of service of roads without bicycle infrastructure. Summation of all the coefficients of the variables in the regression model reveals a z-score of minus 1.097, which implies LOS of C, which is an average. This shows that present condition for bicyclists traveling without bicycle infrastructure is not suitable enough. Further, marginal effects are developed for the same model to understand how a unit increase in one variable results a change in overall satisfaction. The model shows highest probability of 40% for overall satisfaction level 2. The following table shows the effect of one unit change in the variable, for example, number of pedestrians on different level of satisfaction. Next, a GIS-based approach of service area analysis was used to determine extent of the study area by demarcation of catchment boundaries of various commercial hubs in the study area to investigate potential number of travelers using a preferred route to access these areas. So, it can be summarized that all these articulated attributes seem to be the most important factors determining the intention to use bicycle, while others seem to be dominant factors while calculating the BLS for overall satisfaction. Finally, Getting towards interventions. First, a closest facility map was developed with a cutoff value of 600-meter distance that was calculated using the stated preference data on maximum and desired distance one can bicycle from origin or destination point to avail the bicycle path facility. Hence, all required destination points were covered by minimum one facility in the indicated range. In this way, we can also acquire the shortest path traveled by the users to avail the facilities. Next, all the roads were prioritized with PCU values 200 and were demarcated for provision for segregated bicycle tracks. This helps to ensure cyclists have safety and directness. Then, overlaying was done to find out best possible route for interventions with respect to the catchment coverage. This helped in identifying which routes are overlapping each other that can be eliminated, and further, which new road links can be added to ensure the coverage of routes. This network density is to ensure there is less or no conflict between motorized and non-motorized traffic. It will help in determining which road requires traffic calming measures and also help in marking out road links which requires upgradation or new construction for improvement. The table provides with a summary of all interventions on the identified road links based on network density for improvement of bicycle infrastructure. It compares the existing condition of roads on factors such as design speed, road widths, the road typology, and so forth with IRC and IUT standards to show the present scenario. Finally, statement of recommendations for each road link is worked out. Proposal also includes incorporation of preferable policies and guidelines favorable to the development of this project. Next, a scheme is proposed to overlook the process of implementation of such kind of projects. The scheme includes identification of target groups, setting up centralized transport agencies for operation and management, identification of law and enforcement department, and finally, periodic auditing of the program. The following figure illustrates the hierarchy of proposed organizational setup, which includes a specialized transportation cell which will look after such kind of projects. So, it can be concluded that user perception attributes play an important role in defining mode choice and route selection criteria. This study helps in reducing the use of private vehicles for shorter distances and also helps in identifying routes required for improvement based on its function. Since the city is already under construction phase of metro rail project, the network will be useful as feeder service to the metro station. Further, many efforts are being taken to introduce a new mode in the city. This study will definitely help in route optimization for the overall accessibility improvement plan. These were the references taken for the study. Thank you for your attention.